Hello everybody. We have mentioned in the previous video the Pauli exclusion principle, and in this video we're going to talk about some other theories that have very important contribution of the understanding of the nature of the electrons and the shape of the atom in general. The first is Erwin Schrodinger's equation, and Schrodinger equation is a very famous equation, and this equation was the base of the one of the bases of the quantum mechanics or the quantum mechanical systems. To understand what we mean by quantum mechanics, let's just remember something that we studied in the high school. If you have a ball or something, and this ball is falling from a high elevation, and it's falling to the ground, and you want to calculate the time that's going to take till it falls into the ground, and you can simply do that by applying the Newton equations. And the Newton equations are valid for a lot of systems, and it's very accurate, and it can easily be used to predict the time and the location and the velocity of particles or of bodies, and this is okay. But the systems that are very small, like the atoms and the subatomic particles, the classical mechanics equations cannot describe these systems well. And this is because the Newton's equations didn't take into account some other forces, which are not of interest in our daily systems, like in our sizes. But in very small particles like electrons, neutrons, and the subatomic particles, there are some other forces that are very important, and they might be more important than the gravitational forces and the frictional forces that Newton includes in his equations. Among these forces are the magnetic forces, for instance, the electric forces, and all these forces are very critical in subatomic systems, or the atomic systems like the ones that we are talking about now. And that's why Schrodinger, he put his mathematical formula. You see that this formula is, of course, it's not that simple. It's a complex equation, and there is a very difficult mathematical or complex mathematical derivation till he reached this part. And this is a function, and this is a function, so it's not just a symbol. It's a function which is describing different parameters in the system. And this, I'm not going to go into the details of this because I personally do not understand it well. It's not, and it's out of the scope of this course. So there's no point of talking about this. Anyway, so this is, I'm just mentioning this because Schrodinger's equation told us how we can model the electrons and how we can describe them in the form of equations. And then the next scientist is Heisenberg, and Heisenberg, he put his again, it's a mathematical derivation, and it's based on the quantum mechanics, of course, and he stated that it's impossible to predict the momentum and position of the electron in the same time. So again, in the classical mechanics, you can calculate or predict the location and the velocity of a body. It's not a big deal. You can do this easily. But in quantum mechanics, it's impossible, according to Heisenberg's equation, that it's impossible to predict the momentum and the position of the electron in the same time. And his equation said that if you could increase the precision of the calculation of the position, then the calculation of the momentum or the speed is going to be very low. So you can either get this or this. And again, it's sometimes people talk about this as a philosophical model or a philosophical principle, because it's not something that people would really worry about to know where the electron is exactly in the current in this time. Electrons are moving, and it might not be of interest to a lot of people, but it is a principle that is, I think it was proven to be right. And that's why the electrons are now predicted, or the location of electrons predicted to be as an electron cloud. You can never tell where the electron is, but you can tell using a density function where the possibility of the electrons to be more than in other places. So you can see that in this place the dots are dense here more than they are here. So there is high probability of the electrons to be here than there. Again, it's just telling you where the electrons would be more probably around the nucleus. So this is all. In the next video, I'm gonna give a very quick review on the scientists that we mentioned in the previous video, as just a reminder of how it started and how it developed till we reach at this point. And I'll see you then, inshallah. Goodbye.